Hi friends, in the previous video you have learnt about how to answer the multiple choice questions of level 1. Now in this video you are going to learn about how to answer the multiple choice questions of level 2. Dear friends, these questions appeared in the previous JEE and NEET examinations. So watching this video will help you to answer such type of questions. Okay, so happy learning to all of you. Let us begin with the questions. Question number 1. For the following reaction, the mass of water produced by 445 gram of C57H110O6 is, here the equation is given, 2C57H110O6 S plus 163 O2G gives 114 CO2G plus 110 H2OL. Okay, so here are the options. A 490 gram, B 445 gram, C 495 gram, D 890 gram. Okay, dear friends, this question was asked in JEE Mains 2019. Okay, now in this question you are required to find out the mass of water that is produced by 445 gram of C57H110O6. Okay, now according to the equation, 2 moles of C57H110O6 reacts with oxygen to form 110 moles of water. Okay, so first of all we have to convert this 2 moles of C57H110O6 and 110 moles of water in terms of gram by making use of the molar mass. Okay, so 2 moles of C57H110O6 equal to 2 into bracket 57 into 12 plus 110 into 1 plus 6 into 16, that is equal to 2 into bracket 684 plus 110 plus 96, that is equal to 2 into 890 gram. Okay, now 890 gram is nothing but the molar mass of the C57H110O6. Okay, now this is obtained by adding the gram atomic mass of each of these atoms present in one molecule of the compound. Now in this compound there are 57 carbon atoms, so multiply this 57 with the gram atomic mass of carbon 12. Okay, similarly you multiply 110 with the gram atomic mass of hydrogen, that is 1 gram. Similarly multiply this 6 with gram atomic mass of oxygen, that is 16 gram, and add all these, you will get 890 gram. And if you multiply this with 2, you will get mass of 2 moles of this compound C57H110O6. Okay, now similarly consider 110 mole of water. You know that the molar mass of water is 18 gram. So multiply this 18 with 110, you will get the mass of 110 moles of water, that is equal to 1980 gram. Okay, now according to this equation, 2 moles of C57H110O6 reacts with oxygen and produces 110 moles of water. Okay, it means that 2 into 890 gram of C57H110O6 produces 1980 gram of water. Therefore, 445 gram of C57H110O6 produces how much gram of water? Okay, so mass of water produced by 445 gram of C57H110O6 is equal to 445 into 1980 divided by 890 into 2, that is equal to 495 gram. Okay, so 495 gram is the mass of water produced by 445 gram of compound C57H110O6. So the correct option is C. Next, let us take next question. The minimum amount of O2G consumed per gram of the reactant is for the reaction A. 4 FeS plus 3 O2G gives 2 Fe2O3s. B. 2 mgs plus O2G gives 2 mgOS. C. C3H8G plus 5O2G gives 3CO2G plus 4H2OL. D. P4S plus 5O2G gives P4O10S. Dear friends, this question also was asked in JEE Mains 2019. In this question, you have to find out in which among these four reactions the minimum amount of oxygen is consumed per gram of the reactant. Okay. Now for this what we have to do? We have to take each one of this reaction and find out the amount of oxygen consumed per gram of the reactant. Okay. So we shall begin with the first option. So in the first option A, 4 FeS plus 3 O2G gives 2 Fe2O3s. That means here 4 moles of Fe reacts with 3 moles of O2. Okay. Now here 4 mole of Fe is equal to 4 into 56 gram, that is equal to 224 gram. Here 56 gram is gram atomic mass of iron, so that is multiplied with 4 to get 224 gram. Okay. Now 3 mole of O2 is nothing but 3 into 32 gram, that is equal to 96 gram. So 32 gram is nothing but the molar mass of O2. So here 3 is multiplied with 32 to get 96 gram. Okay. So here 4 mole of Fe react with 3 moles of O2 means 224 gram of Fe reacts with 96 gram of O2. So 1 gram of Fe reacts with how much gram of O2? So mass of O2 reacting with 1 gram of Fe is equal to 96 into 1 divided by 224. That is equal to 0.428 gram. Okay. Let us take the second option. So in second option, 2 mgs plus O2G gives 2 mgOS. Okay, so here 2 moles of magnesium react with 1 mole of oxygen. So 2 moles of magnesium is equal to 2 into 24 gram, because 24 gram is gram atomic mass of magnesium. So 2 into 24 will be equal to 48 gram. And 1 mole of O2 is equal to 32 gram. You know that molar mass of O2 is 32 gram. Okay. So 1 mole of O2 equal to 32 gram. So in the equation 2 moles of Mg react with the 1 mole of O2. That means 48 gram of Mg reacts with 32 gram of oxygen. So 1 gram of Mg reacts with how much gram of oxygen? So mass of O2 reacting with 1 gram of Mg equal to 32 into 1 divided by 48, that is equal to 0.66 gram. Okay. Let us take the third option. So in the third option, C3H8G reacts with 5O2G to form 3 moles of CO2G and 4 moles of H2OL. Okay. So here 1 mole of C3H8 reacts with 5 mole of O2G. Okay. Now 1 mole of C3H8 is equal to 12 into 3 plus 8 into 1. That is equal to 36 plus 8, that is equal to 44 gram. Okay. Now here 1 molecule of C3H8 contains 3 carbon atoms and 8 hydrogen atoms. You know that the gram atomic mass of carbon is 12. So multiply this 12 with 3. And then you know that the gram atomic mass of hydrogen is 1 gram. So multiply 8 with 1. And then add these two. That is 12 into 3 plus 8 into 1. That will be 36 plus 8, that is equal to 44 gram. So 44 gram is the molar mass of C3H8. Okay. Now similarly consider 5 mole of O2. So 5 mole of O2 equal to 5 into 32 gram. Because 32 gram is molar mass of O2. So 5 into 32 gram, that is equal to 160 gram. So 160 gram is nothing but the mass of 5 moles of O2. Okay. So in this equation, 1 mole of C3H8 reacts with 5 mole of O2. It means that 44 gram of C3H8 reacts with 160 gram of O2. Therefore, 1 gram of C3H8 reacts with how much? Okay. So mass of oxygen reacting with 1 gram of C3H8 is equal to 160 into 1 divided by 44, that is equal to 3.63 gram. 3.63 gram. Okay. Let us take the fourth option. So in the fourth option, P4S plus 5O2G gives a P4O10S. Okay. Now in this reaction, 1 mole of P4 reacts with 5 moles of O2. So 1 mole of P4 is nothing but 4 into 30.9, that is equal to 123.6 gram. Okay. Now here the gram atomic mass of phosphorus is 30.9 gram. So one molecule contains 4 phosphorus atoms. So multiply 4 with 30.9 gram, that will give 123.6 gram. So that is nothing but the mass of 1 mole of P4. And you know that 5 mole of O2 is equal to 160 gram. So according to this equation, 1 mole of P4 reacts with 5 mole of O2. It means that 123.6 gram of P4 reacts with 160 gram of O2. Therefore, 1 gram of P4 reacts with how much gram of O2? So mass of oxygen reacting with 1 gram of P4 equal to 160 into 1 divided by 123.6, that is equal to 1.29 gram. In option A, mass of O2 reacting with 1 gram of AP is equal to 0.428 gram. In option B, mass of O2 reacting with 1 gram of Mg is equal to 0.66 gram. In option C, mass of O2 reacting with 1 gram of C3H8 is equal to 3.63 gram. And in option 4, mass of O2 reacting with 1 gram of P4 is equal to 1.29 gram. Okay. Now dear friends, you observe that the mass of oxygen reacting with 1 gram of Ap is the minimum, that is equal to 0.428. So that is the correct option. So correct option is A. Okay. Now we shall take next question. 5 moles of Ab2 weighs 125 into 10 power minus 3 kg, and 10 moles of A2B2 weighs 300 into 10 power minus 3 kg. Full stop. The molar mass of A and B in kg per mole respectively are A 10 into 10 power minus 3 and 5 into 10 power minus 3, B 25 into 10 power minus 3 and 15 into 10 power minus 3, C 5 into 10 power minus 3 and 10 into 10 power minus 3, D 15 into 10 power minus 3 and 25 into 10 power minus 3. Dear friends, this question was asked in JEE Mains 2019. Okay. Now in this, first we have to find out the molar mass of each of AB2 and A2B2. Okay. So first we shall see the molar mass of AB2. So mass of 5 moles of AB2 is given, that is equal to 125 into 10 power minus 3 kg. So if you convert this in terms of gram, that will become 125 gram. Okay. So mass of 5 moles of Ab2 equal to 125 gram. Therefore, mass of 1 mole of Ab2 is equal to, that is nothing but the molar mass of Ab2, that is equal to 125 by 5, that is equal to 25 gram. Okay. Now next let us take the A2B2. So mass of 10 moles of A2B2 equal to 300 into 10 power minus 3 kg. If you convert this in gram, this will become equal to 300 gram. So mass of 10 mole of A2B2 equal to 300 gram. So mass of 1 mole of A2B2 is equal to molar mass of A2B2, that is equal to 30 gram. Okay. So molar mass of AB2 is 25 gram and molar mass of A2B2 is 30 gram. Let the molar mass of A be x gram per mole and molar mass of B be y gram per mole. And we know that molar mass of AB2 equal to 25 gram per mole and molar mass of A2B2 equal to 30 gram per mole. Okay, so we can also write molar mass of AB2 as x plus 2y equal to 25 gram per mole, because one molecule of AB2 contains one atom of A and two atoms of B. Okay, so we can get the molar mass of any compound by adding the molar mass of the individual atoms present in one molecule of the substance. So here one molecule of AB2 contains one atom of A and two atoms of B. So multiply these number of atoms with the molar masses of A and B. Okay, so number of atoms of A is 1 and molar mass of A is X. So 1 into X, that will be X. And similarly here the number of atoms of B is 2 and molar mass of B is Y. So 2 into Y, that will be 2Y. So add these two, it will become X plus 2Y, that is equal to 25 gram per mole. So call this as equation 1. Okay, now similarly for A2B2 molecule, we can write molar mass of A2B2 as 2x plus 2y equal to 30 gram per mole. Okay, now here the one molecule of A2B2 contains two atoms of A and two atoms of B. Okay, so for this also we have to add the molar masses of A and B. Okay, so number of atoms of A is 2 and molar mass of A is X, so that we have to multiply 2 and X, that will become 2X. Similarly for the molar mass of B is Y gram, and multiply this with the number of atoms of B, that is 2, so that will become 2Y. So add these two, 2x plus 2y, that will become equal to 30 gram per mole. So call this as equation 2. Okay, now these equations 1 and 2 are the linear equations. So using these equations we can find the value of x and y. Okay, so for that we have to subtract equation 1 from equation 2. So for subtracting these equations, what we have to do is we have to subtract the left hand side of equation 1 from left hand side of equation 2. Similarly, right hand side of equation 1 from right hand side of equation 2. Okay, now first let us take the left hand side. So left hand side of equation 2 is 2x plus 2y, and left hand side of equation 1 is x plus 2y. Okay, so left hand side of equation 2 minus the left hand side of equation 1, that will be 2x plus 2y minus of x plus 2y. Okay, so this will be equal to 2x plus 2y minus x minus 2y. So plus 2y and minus 2y will get cancelled. So you are left with the 2x minus x, that will be x on the left hand side. Okay, now you take the right hand side. So right hand side of equation 1 is 25 gram per mole. Right hand side of equation 2 is 30 gram per mole. Okay, so right hand side of equation 2 minus right hand side of equation 1 will be 30 minus 25, that is equal to 5 gram per mole. So the value of x is equal to 5 gram per mole. Okay, now use this value of x to find the value of y. Okay, so for that you substitute this value of x in equation 1. So equation 1 is x plus 2y equal to 25 gram per mole. So here x equal to 5 gram per mole. So substitute the value of x here. So you will get 5 plus 2y equal to 25. So you have to transfer 5 from the left hand side to right hand side. You will get 2y equal to 25 minus 5, that will be 20. So 2y equal to 20 or y equal to 10 gram per mole. Okay, so we know that x equal to 5 gram per mole. If you convert that into kg per mole, it will be 5 into 10 power of minus 3 kg per mole. Okay, now similarly y equal to 10 gram per mole, you convert this into kg per mole, that will be 10 into 10 power of minus 3 kg per mole. Okay, so the correct option is third option, that is C. Let us take the next question. Question number 4. The mass of a molecule of a compound C60H122 is A 1.4 into 10 power of minus 21 gram, B 1.09 into 10 power of minus 21 gram, C 5.025 into 10 power of 23 gram, D 16.023 into 10 power of 23 gram. Dear friends, this question was asked in NEET 2000 examination. Okay, now in this question you have to find the mass of a single molecule of the compound C60H122. So for this you have to consider the molar mass of the compound. Okay, so molar mass of C60H122 is equal to 12 into 60 plus 1 into 122, that is equal to 720 plus 122, that is equal to 842 gram per mole. Okay, so 842 gram per mole is the molar mass of this compound C60H122, and it is obtained by adding the molar mass of carbon and hydrogen. So here this one molecule of the compound contains 60 carbon atoms and 122 hydrogen atoms. So 60 is multiplied with the gram atomic mass of carbon, that is 12 gram, and added to the gram atomic mass of hydrogen, that is 1 gram, which is multiplied with 122. Okay, so you will get 842 gram per mole as the molar mass of this compound. Now this 842 gram per mole of this compound contains Avogadro number of the molecules. Okay, so you can see that here 842 gram of the compound contains 6.022 into 10 power 23 molecules, that is Avogadro number of molecules, or mass of the Avogadro number of molecules, that is 6.022 into 10 power 23 molecules, equal to 842 gram. So mass of one molecule of the compound equal to how much? Okay, so mass of one molecule of the compound equal to 1 into 842 divided by 6.022 into 10 power 23, that is equal to 139.82 into 10 power minus 23. Okay, so you can express this in terms of scientific notation. So mass of one molecule of the compound equal to 1.39 into 10 power minus 21 gram. Okay, now dear friends, this 1.39 can be rounded up to 1.4. Okay, so that will be equal to 1.4 into 10 power minus 21 gram. Okay, so the mass of one molecule of the compound is equal to 1.4 into 10 power minus 21 gram. So the correct option is option A. Okay, we shall take the next question. Question number 5. What is the mass of precipitate formed when 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% solution of NaCl? Here the atomic masses of the elements are given. Atomic mass of silver Ag equal to 107.8 U. Atomic mass of nitrogen N equal to 14 U. Atomic mass of oxygen O equal to 16 U. Atomic mass of chlorine Cl equal to 35.45 U, and atomic mass of sodium Na equal to 23 U. And here are the options: A 28 gram, B 3.5 gram, C 7 gram, D 14 gram. Okay. Dear friends, this question was asked in the NEET 2015 examination. Okay. Now in this question, it is given that 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% solution of sodium chloride. Okay, so when you mix these two solutions, a precipitate of AgCl is formed, and following reaction takes place. Okay, so we can see the equation: AgNO3 plus NaCl gives AgCl plus NaNO3. Okay. Now in this reaction, 1 mole of AgNO3 reacts with sodium chloride to form 1 mole of AgCl. Okay. So first let us find the molar mass of AgNO3 and AgCl. Okay. So 1 mole of AgNO3 equal to 107.8 plus 14 plus 3 into 16, that is equal to 107.8 plus 14 plus 48, that is equal to 169.8 gram. Okay, so dear friends, 169.8 gram is the molar mass of AgNO3, and it is obtained by adding the gram atomic mass of all the atoms present in one molecule of AgNO3. So AgNO3 contains one silver atom, one nitrogen atom, and 3 oxygen atoms. So we have to add the atomic mass of all these 3 elements. So 107.8 gram is the gram atomic mass of silver, plus 14 gram, that is the gram atomic mass of nitrogen, plus 3 into 16, that is the gram atomic mass of oxygen, into 3, that will be 3 into 16. So if you add all this, you will get 169.8 gram. Okay, so 169.8 gram is the molar mass of AgNO3, that is mass of 1 mole of AgNO3. Okay, now let us find the molar mass of AgCl. So this is obtained by adding the gram atomic mass of silver and chlorine. Okay, so gram atomic mass of silver is 107.8 gram and gram atomic mass of chlorine is 35.45 gram. If we add these two, you will get the molar mass of AgCl, that is 143.2 gram. That is mass of 1 mole of AgCl. Okay. Now, dear friends, in this question, it is given that 50 ml of 16.9% solution of AgNO3 is mixed with 50 ml of 5.8% solution of NaCl. Dear friends, here 16.9% of solution of AgNO3 means if you take 100 ml of this solution, it will be containing 16.9 gram of the AgNO3. Okay, that is 100 ml of this AgNO3 solution contains 16.9 gram. Okay, but remember, in this we are not mixing 100 ml, we are mixing 50 ml of this solution. Okay, so we have to find out the mass of AgNO3 present in 50 ml of the solution. Okay, so 100 ml of the AgNO3 solution contains 16.9 gram. Okay, so look at this here. So it is given that 100 ml of AgNO3 solution contains 16.9 gram of AgNO3. Therefore, 50 ml of the solution contains how much gram of AgNO3? Okay. So mass of AgNO3 present in 50 ml of the solution will be equal to 50 into 16.9 divided by 100, that is equal to 8.45 gram. Okay. So 8.45 gram is the mass of AgNO3 present in 50 ml of the solution. Okay, but according to stoichiometry of the equation, you know that 1 mole of AgNO3, that is 169.8 gram of AgNO3 forms 1 mole of AgCl, that is 143.25 gram. Okay, therefore 8.45 gram of AgNO3 forms how much gram of AgCl? Okay, so mass of AgCl formed equal to 8.45 into 143.25 divided by 169.8 gram. Okay, so this is equal to 7.12 gram. Okay, so the correct option is third option, that is C. Okay, I hope we have understood how to answer this type of questions. So I wish you all the best. Let us meet in the next video. Okay.